The amount of water a community uses every day can be expressed in terms of an average daily flow, or ADF. Average daily flow equals the sum of all daily flows divided by the total number of daily flows used. ADF is important because it's used in a number of treatment plant calculations. Another key formula for water treatment is that for determining the surface overflow rate. The faster the water leaves a sedimentation tank or clarifier, the more turbulence is created and the more suspended solids are carried out in the effluent. Overflow rate, the speed with which water leaves the sedimentation tank, is controlled by an increase or decrease in the flow rate into the tank. The surface overflow rate measures the amount of water leaving a sedimentation tank per square foot of tank surface area. The treatment plant operator must be able to determine the surface overflow rate that produces the best quality effluent leaving the tank. Since surface overflow is the gallons per day of flow per square foot of tank surface, the corresponding mathematical equation is surface overflow rate equals flow in gallons per day divided by tank surface in square feet. The calculation of Weir overflow rate is important in detecting high velocities near the weir, which adversely affect the efficiency of the sedimentation process. With excessively high velocities, the settling solids are pulled over the weirs and into the effluent troughs. Since Weir overflow rate is gallons per day flow over each foot of weir length, the equation for the Weir overflow rate is equal to flow divided by weir length. The filter loading rate is measured in gallons of water applied to each square foot of surface area. Filter loading rate measures the amount of water flowing down through each square foot of filter area, measured in gallons per minute per square foot. The formula is filter loading rate equals flow divided by filter area. Sometimes the filter loading rate is measured as the fall of water in inches through a filter per minute. That is expressed mathematically as filter loading rate equals inches of water fall divided by minutes. The filter backwash rate is measured in gallons of water flowing upward each minute through a square foot of filter surface area. The units of measure for backwash rate are the same as those for filter loading rate, that is gallons per minute per square foot of filter area. That equation is filter backwash rate equals flow in gallons per minute divided by filter area in square feet. Sometimes the backwash rate is measured as the rise of water in inches that occurs each minute, and so is written as filter backwash rate equals inches of water rise divided by minutes.